Heisenberg group, the three-dimensional case, continuous Heisenberg group. If A, B, C are real numbers in the ring R, then one has the continuous Heisenberg group H3R. It is a nilpotent real Lie group of dimension 3. In addition to the representation as real freaks 3 matrices, the continuous Heisenberg group also has several different representations in terms of function spaces. By Stone-von Neumann theorem, there is up to isomorphism, a unique irreducible unitary representation of H in which its center acts by a given non-trivial character. This representation has several important realizations, or models. In the Schrödinger model, the Heisenberg group acts on the space of square integrable functions. In the theta representation, it acts on the space of holomorphic functions on the upper half plane. It is so named for its connection with the theta functions. Discrete Heisenberg group. Heisenberg group modulo and odd prime p. Heisenberg group modulo 2. Heisenberg algebra. Higher dimensions. Group structure. Lie algebra. Exponential map. Representation theory. On symplectic vector spaces. The connection with the Weyl algebra. Applications. Weyl's parameterization of quantum mechanics. The application that led Hermann Weyl to an explicit realization of the Heisenberg group was the question of why the Schrödinger picture and Heisenberg picture are physically equivalent. Abstractly, the reason is the Stone-von Neumann theorem. There is a unique unitary representation with given action of the central Lie algebra element Z up to a unitary equivalence. The non-trivial elements of the algebra are all equivalent to the usual position and momentum operators. Thus, the Schrödinger picture and Heisenberg picture are equivalent. They are just different ways of realizing this essentially unique representation. Theta representation. The same uniqueness result was used by David Mumford for discrete Heisenberg groups in his theory of equations defining abelian varieties. This is a large generalization of the approach used in Jacobi's elliptic functions, which is the case of the modulo 2 Heisenberg group of order 8. The simplest case is the theta representation of the Heisenberg group, of which the discrete case gives the theta function. Fourier analysis. The Heisenberg group also occurs in Fourier analysis, where it is used in some formulations of the Stone-von Neumann theorem. In this case, the Heisenberg group can be understood to act on the space of square integrable functions. The result is a representation of the Heisenberg groups, sometimes called the Weyl representation. As a sub-Riemannian manifold, Heisenberg group of a locally compact abelian group